Unit 5, Assessment 1 Review Preview. All right, here we go. Let's see. Last class, we put above the word inverse. Anybody know the word we put above the word inverse? Yeah. Inverse and a reverse are kind of what you want to think. Someone asks you to find the inverse of an equation with 2 letters, and it must have 2 letters. Step 1, you just reverse the order of them. We're going to get answers now. Step 1, we reverse it, so now the x and the y have traded places. Over here, you reverse the x. I wish I had different colors. I probably do. It might be hard to get to them. X and the y change places. The last step after the x and y change place is going to be to solve for the y. In other words, get y alone. So y started off alone. You reverse the order, and then you get y alone again, and voila, you win the game. So finding the inverse of an equation is as easy as the equation is. If there's a lot of stuff in the equation, then finding the inverse is a lot to do. If it's just one move, then it's one move. Here we go.
Is there stipulated?
Should be around there over there. So let's see what I would do to get this y alone. I should have created some space, so let's see if I can do this. I'm going to rewrite this one so I can have some space, because I'm about to do something. If ever you need to get something down from the sky, if you were to tie a log onto it, that balloon would drop down to the ground, and therefore I'm going to tie a log. Can I get tie a red? Oh, man. No. Okay. All right, here comes. To get this W down, I write the word log in front. I'm going to tie a log onto that W, onto that Y. What I did on one side of an equation, I must do to the other. We're halfway done. From there, what will happen next is the Y that's floating up high will come down in front of the log, which is the point of it. And the good news is once that y is in front of log 3, it'll be y times log 3. How do you get rid of a times? You divide both sides by whatever you're multiplying by. You'll see what I mean in just a second. Hey, y times log 3, who cares what it means? Just the steps. Y times log 3, I need to get y alone. Anytime I'm multiplying something times something, I divide that thing on both sides. And voila, I am done. Log 3 on that side, log 3 on this side. Voila. Y equals log x over log 3. By the way, the word log stands for long word logarithm, which has to do with the opposite of raising something to a power. But let's just pause here. What did we find? We found the inverse or the reverse of this original problem. That's what we found. We're going to find the inverse, the reverse for this one and that one. You look at them, they will be there. So I don't know if they'll be the exact same problem, but the concept will be the same. Switch letter, solve for the y. Here it comes. Step 1, when you get rid of stuff, if you saw The Life of Pi, the movie, you know when you're surviving something, you got to get rid of some stuff to survive. Well, in this world here, if you're on The Life of Pi, you get rid of your cousin first. They go overboard. Second, your sister or brother, they're closer to you. And then lastly, it's just you trying to survive. So let's see if we can do that. Let's do the opposite by subtracting, adding 6 to both sides. Like regular old, it's like regular old math. X plus 6 equals the 5 y squared. So part of this test is going to be easy, which is why I want you to take some of it today. I got to get rid of the 5 second. 5 on both sides. Under the whole thing, I want it with this x plus 6, y squared. And the last thing, anybody know what the inverse or the reverse of squaring something is? Someone kind of whispered it. All right, square rooting. It is the opposite. square root on this side. Whatever you do on one side, you must do on the other. And so the 2 and the house cancel, leaving just a y. And then on this side, everything that was there stays there. So you're not getting kind of like a number answer. You're just seeing, can I go through this process of reversing things? I'm going to pause and let you look at it for a second. The answer is, but 2 at the very end, after you struggle with it a little bit, then it's appropriate to allow you to at least try it now with your notes. Let's do it with a red. Plus 3, a negative 5y. I'm going to divide that 5 on both sides, and I'm done. All right, let's do that in a different color. So you can see if someone misses class, really, I'm not that guy, but now that we're at the end, it doesn't really matter. But I would maybe strategize. Maybe I would take Mondays off and then really actually watch the video, you know, get whatever it is I need. But it's really the same as being here, except it's shorter because I pause it. So anything in between when we're waiting for people to answer the question, or one piece. Hey, what's the inverse of a ordered pair? You're just reversing the order. Who was X, you become Y, and who was Y, you become X. So let's see, if you are X and you are Y, hey, find the inverse of that. I'm going to put down that now the 6 is the X, and the 0 is the Y. That's it. That's the inverse, the reverse. If you didn't do any of those, you can just mess around with them. These are called braces. The pointy guys are braces. The brackets are the square guys. Parentheses are the round guys. I'm going down to the bottom section. I don't know how much I did on it, but I'm going to try 1 or 2 of them. They're all completely different. All right. First thing I want you to do, I know we did last time. If there is a problem that has an equal sign, he is complete. He has everything that he needs. If there's a problem without an equal sign, technically you don't need it, but for our purposes, so it follows the rhythm, the pattern of the original guy, we're going to put equals, and since we don't know what it equals, you get to choose a letter. X is a famous guy. Could you put equals a question mark? You could. Could you put equals your initial, a T? You could. Could you put equals N? N is the next one they do. Changing all the letters is probably a bad idea. I probably should have put X on all of them. X is the famous letter because, again, as I mentioned last time, the people learn created algebras in a different language, and when they translated from the original language to this one, unknown started with the letter chi, and I think it's Greek. And so when that letter translated, the closest thing they had to it was the letter X. Hence, the unknown is X. All right, Tom, hey, get some answers. Can I get some answers? Here's what I'm going to do. You see this bottom number? We call it the base. The base. Anybody know what the base is in C? When there is no base, it is a 10. That 10 is hooked onto the little G. Someone say what the base is on D, please. I'll ask, it's weird. What's the base in E? In E, they've done some of the work for us, which is unfortunate. Like this, I wish I had a highlighter. We circled this 2. Circle that 2. They did what you're about to do to all these problems. That is, when you see the log and you need to solve a problem for it, there are more than one way to say this thing. This is the way I'm going to do it, and hopefully it's as easy for you as it is for me. Hey, Thomas, to get to X, I need to get rid of this log 3 thing. Log is the opposite of what we did up there to bring a balloon down. So log is the opposite of raising something to a power. So how do I get rid of a log? I raise it to a power. What does that mean? Here's what it means. I take the base and I write 3 as, now it's 3 raised to this power. Like log is now in the power, it's up in the sky. But you do to one side, you must do it to the other. There's another way to say it. I'm going to try it this way and see how it feels. Okay. You raise it to the log. Step 2. The 3 and log base 3 cancel out. By the way, if that was a base 4, you put a 4. If it's a base X, you put an X. Base 10, you put a 10. The red 3 depends on what was there to begin with. I'm about to cancel some stuff out and be like, oh shoot, I'm at the answer. No, something's not right. Okay, watch this. The log and the base cancel each other, leaving just an x. On the other side, we had 3 raised to the -2 power. Look at it, see how it feels. The only thing you need to know now, which technically if we have a calculator, which breaks my heart, but whatever. Anybody know what 3 raised to the -2 power equals? Okay. 9 is going to be close. 9 is going to be part of the answer. Well, for any negative exponent, what does the answer have to look like? No matter what the exponent, but if it's negative, the answer has to look a certain way. Yeah, it's kind of vague. It has to be a fraction. The answer has to be a fraction. A negative exponent says, it's the math guy's way of saying, I don't want to write a fraction. Is a way I can show the problem, but without actually writing the fraction? Yeah, this way. The top number will always be 1. The bottom will be the original problem without the minus sign. The original problem without the minus sign. Take a look at it, see how it feels. It is true. Once you get rid of the negative sign, then you just do 1 over 3 squared, which that 9 you mentioned is there. The only thing that should make this this work difficult is remembering all the pieces, but none of the pieces are hard pieces.
And the answer is correct.
I raise everything to the 4th power, but I want to do it in red so that you can feel the rhythm, the pattern. I raise the whole thing to the 4 on this side. What I do to one side, I must do to the other. Those 2 guys cancel out. I'm left with the 64 equals the 4 raised to the x power. At this point, do 4, right under the play button, caret, put in a 3, and see if it says 64. It should say 64, 2 of them, so they can have 4 to the 2nd power equals 16, 4 to the 1st power equals 0, 4 to the -1 power equals a 1 over a 4. Let me deal with x's. X's don't make any sense, so let's make it to the 3. 3 to the 2nd power equals a 9. 3 to the 1 power. Oh, I missed my 0. This is wrong. This line here is wrong. 1 power equals a 3. You are wrong. Okay. Let's do that part. All right. 4 to the 0 power equals a 1. You equal a 4, and your friend down here equals a 1 over you. 3 to the 0 power equals a 1. This line here gets a star. 3 to the -1 power equals a 1 over 4. Oops, over 3 rather. I'll say it briefly. Any number to the 0 power equals 1. Any letter to the 0 power equals 1. Why? Because to get from one row down to the next row, you divide by whatever the base is. Like, what does he mean? To go from this row here, the square, you divide the 9 by a 3, which gets you a 3. 9 divided by 3 is 3. To go from this row to this row, you divide the 3 by the basis of 3. 3 goes into 3 one time. And then this next line, to go from this row to this one, it's a 1 divided by a 3, which is a 1 over 3. May not matter. Write it down. Last piece, let me put this x. The 0 power is 1, because any number to the 0 power is 1. And the next line below is 1 over that letter. All right, let me solve some of these other problems. Just get on your paper. I'll jump to one other section, maybe try and draw a picture as it's time to start tasting that thing in a second. Hey, Thomas, what are you going to do for this one? The base is 10. Well, you know what? Easy trick question. If I had power, I'd write the 2 in red. They already put in the number. So this is going to be a weird problem. It's going to be a weird problem. Real fast. If they did it properly, they put like a red 10, red 10. They wound up putting a line through in green, leaving up with 10,000. 10 to some power. On their calculators, you push in a 10, put the caret symbol below clear, and push in a 2. Oh, that's 100. Push in a 3. Oh, that's whatever. Anybody know what the actual number is going to be? If not, that's fine. You'll punch in your calculator, you'll find it out. Down here on D, if you did D properly, hopefully you're catching the rhythm. Math is about a pattern. Half people are good in math. They don't even have to know what they're doing. Oh, I see the pattern. Okay. People are not good at math, you're just not good at patterns. Well, not just, but that can be one of your challenges. You just don't see the rhythm, like, I don't get what he did in the last one. So you see the pattern and you're like, oh, that's so easy. Last question on this one. 3 raised to what power? Who's going to give us a 1? Anybody know? Okay.
0.
So when you figure that out, you can. I'll also mention if you look over to the chart over to your right. The good news will be any number raised to the 0 power equals 1. So if it equals 1, you know it's 0. Why? Because of dividing, but maybe the y. I'm not a big y guy in math. Turns out Tim is a big y guy. He likes y. But if you know y, then it all makes sense in y. I've seen too many people get lost in y. So I'm like, all right, I hear
What about Brandon?
that dude loves everything. Yeah, he's just like, I love math, I'll do movies, I'll teach movies, I'll do English with his degrees in English. He doesn't even have a degree in math, he's just genius. So he could be the English teacher, but since Stacy was already Englishing, you know, they're not genius. All right, here comes this guy here, look at the red 2. The red 2 is doing to the log 2, where the 3 did to the log 3, the 3 did to the log 3, the 4 did to the log 4. Do me a favor, see if you can try and get these.
Cancel out log 2.
Yeah. So I'm not sure why they already put in the 2s for us, but whatever, we'll take it. Once you do that, believe it or not, you are doggone done. Like, how do you know you're done? Well, when the letter's alone and there's just one number on the other side, in math we call that solving an equation. It's the solution. It's what the letter equals. Also, I should have been saying all along, people are behind or find things difficult, go to the tutor, it's free. Normally in real life it costs like $50 to have it. On A, I'm going to scratch out the 3 because it doesn't go with at least my skill set, my knowledge set. And every other problem doesn't have a 3. Anybody know what numbers are on the G's on all the other problems? There's a number when you don't see a problem, what number it is? Good. See people at home? All right, it is a 10. There is a little 10 whenever you don't see it. Now, in the world of math, we don't write this 10. I'm writing it so, because you're new, this is like putting x to the first power. Like x to the first power plus x. We don't put the first power on x's. Because it's understood that if there's no number, it's all right, so here's the deal. This silly question that they're asking you, you gotta do it without a calculator. Okay, fine. You need a little key up here. It says here, for each of the following, and without using a calculator, between what 2 numbers, circle that, that'll be important, does each lie? For instance, given log 5, they give you a little example here. You got log 5, they didn't put the 10, and I'm eventually gonna stop on it. We know that the log, we know that 0 equals log 1. Okay. We also happen to know that log 10 happens to equal 1. Let me do a few more of these log things that you'll need. You'll need that the log of 100 equals something. The log of 1,000 equals something. I'm going to see who gets the pattern, then they can give it to us. And so on. One more log. The log of 10,000. You get your 10,000? 1, 2, 3. Here it goes. Hey, anybody know? Yeah, count the 0. Anybody know what the log of 100 might be? The log of 10 is a 1. The log of 1 is a 0. So again? Heard of 10. Okay, not quite, but once you catch what you're looking for, then it'll be way easy. I just want to do it for 2. 2 is it. How did you know 2? How did you were able to guess 2?
0.
Uh-huh. Anybody know what the log of 1,000 is? How about the log of 10,000? Right. The question being asked here is basically 10 raised to what power? 10 raised to what power will give me a 100? Oh, 10. Oops. Just so you can feel it. Eventually, you'll start to feel it. 10 raised to the second power gives me 100. 10 raised to the third power gives me 1,000. 10 raised to the fourth power equals 10,000. Look, step one. Whatever number is next to the log, I'm going to write a number that's smaller than it and bigger than it. But they have to be powers of 10. What does he mean? He'll show them. We're going to put 100. 100 is bigger than 86. It has to be on this list. Here's the last guy. There's a 10. There's a 1. I got to figure out how to get a negative 1. But for now, I'll use those.
Comments? I'm missing that paper.
All right. Check on the back table. Oh, for real?
Yeah.
Did she not make that?
Oh,
Oh, man. The regular people, you have yours, right? Yeah, regular people, right? Other people write on your paper until we can get you the copy, and you just copy down. All right, look at that. 86 is between 10 and 100. Well, how does he know to choose between 10 and 100? My choices are the numbers up here on these log guides. These are all the choices I have. I can only put down powers of 10. Okay, I'm going to do it again on the 2000. 2004 rather, of these red circle numbers, I need to find the number that's just bigger than it and the number that's less than it. In other words, this is 2000. Okay, 2000 not bigger, so I can't use that. Who's the guy next to that is bigger? So the 10,000 gets to be on the right-hand side, and the guy right behind him winds up on the left-hand side. Take a look at that, see if you're okay with the numbers I chose. Because you're about to do the same thing on D and F are regular numbers. And I want you to choose of the red circled numbers, who is the number larger, just to the right of 300, of those numbers. And then, of course, the partner is going to be the one right next door to it. And then for those who get it, to do it with the 87 is not a big deal. What did I do? Who's bigger than 86 on this list? 100. Somebody was like, well, duh, 1,002. No, it has to be the next guy bigger. Like, you can't be like, oh, it's 10,000. Yeah, they're bigger, but it has to be the next guy above. Watch this guy here. Who's the next guy above 2,000? Okay, 1,000's too small. Oh, 10,000 next guy in line. So that's how you're choosing for D and F. Go ahead and try. I'm about to ask log of 110. 0.1 is a negative 1. Do you have any negatives? Yeah, -8. Decimals. I guess that'll do. Okay, so I just need this extra log 1 here. All right, let's find out. See, so someone on this side of the room, then someone on that side of the room. What was the number that's bigger than the 305? This side of the room over here. All right, 1,000, I believe it. All right. Someone on that side of the room, what's the number that's bigger than 87? Yeah. All right. Once you get one of the numbers, the other guy is the next guy in line. In other words, let's see. They chose 1,000, then 100 is the one right above them. This number here is trapped between those two. And then this is 87 over here. 100, the guy below him is a 10. Take a look at it, see if you follow what the numbers are coming from. Trick question. All right, how about this E? Anybody is able to think about E? Or can say it now? What number is above 6 cents? I don't know if that's the best way I would say it. No, this thing isn't. Yeah, that's why I did it wrong, man. 10 is a good choice, but it's a better choice. Yeah, the one. This isn't even $1 yet. Okay, yeah, that's what it should have done. $1, and who's below $1? This thing over here that I just did. Something feels wrong about that. This one, if they put it on there, I'm gonna give credit for putting in numbers. I'm gonna put in mine, but I believe mine is wrong. What sounds like this is wrong? Because this 0.1 represents 10 cents, and this isn't even 6 cents. But even if it was 6 cents, 10 cents is bigger than it. But we don't have the next guy on line, so question mark on this one. If he shows up, write something down, and you're going to be in a good position by just writing down. Hey, Thomas is getting an answer, getting the test. It's beyond the time I intended, but these are so easy that I'm going to let them get it. Here it comes. Step one, once you put in the numbers, you actually have to write in the word log in front of each one of them. I'm going to do it to a few of them, and then it'll be enough for your test. Once you have in the word log, you have a little chart over here. That says a log of 100 is a 2 because it has 2 zeros. A log of 1,000 is 3 because it has 3 zeros. A log of 10,000 is a 4 because it has 4 zeros. They actually want the actual numbers that this log 86 is between. Like, what does it mean? Log of 10 is a 1. The log of 100 is a 2. And how are they going to write it? They're going to write it like this. So 2 less than symbols and the original thing in the middle. Take a look at it, see how it feels. Granted, you use your notes. This part might just be for those that, okay, you're whatever. I'm going to do it again. Well, everyone try to do it right here. All right, grant now. Write the word log on both. I might even underline the zeros. I got 3 of you. I got 4 of you. And with the original thing, you just get rewritten in the middle. Count the zeros. Write the original in the middle. I'm going to count the zeros on F. And then write. Now, yes, you can't just put a 10. It has to actually be log that. And now count the zeros. There's 1 of you. There's 2 of you. Less than, and the thing in the middle.